And so now we'll move on to problems 19 and 20. The problems are getting slightly more difficult as we go along. And number 19 is asking us to talk about triangle ABC and it's being congruent to another triangle. So what other triangle is in this figure? Besides ABC, can you identify the other triangle? The other triangle that's drawn in is triangle ADC. Okay, it's this triangle here on the right, ADC. So the question is ABC congruent to ADC? So what are we given? We're given that AD is parallel to BC and that AB is parallel to CD. Okay, so it's what we're going to learn in not too long a period of time is known as a parallelogram. It's a four-sided figure here where both opposite sides are parallel to each other. So the question is ABC congruent to ADC? And to answer this question, I'm going to try to write this out by separating the two triangles out. I mean, we can't do this physically in reality, but we can do it in our minds, right? So let's go ahead and let's separate out ABC and ADC like this. Okay, so I've kind of broken it up into two different triangles, and let's try to figure out what corresponding sides and or angles would be congruent. Well, we just learned or just refreshed our memory about the alternate interior angles theorem, right? If two lines are parallel, then alternate interior angles are congruent or have equal measures. So let's go ahead and try to remember what that means. Let's extend these lines out a little bit, make these look a little bit more like lines. Let's extend line AC out so it looks like a transversal. Can you remember which angles are congruent here? Which are the alternate interior angles? Well, if we're looking at AD and BC as parallel lines, then that means that angle 1 and angle 4 are alternate interior angles. So angle 1 is congruent to angle 4. Okay, good. Is there anything else that we can conclude? Well, we have another pair of parallel lines here, AB and CD, which we can also extend. And we can now look at AC as being the transversal. So we've got this line parallel to this line with this transversal, and I think you'll agree that in this case, angles 3 and angles 2 are alternate interior angles. If it helps you at all, we can turn this sideways, and you can see that if we put parallel lines on top and bottom, then that makes angles 3 and 2 alternate interior. So we can conclude quite a bit from these parallel lines the way they're drawn. And so let me go ahead and mark these markings in on this drawing that I've done. So we have ABC. We said that this angle was congruent to this angle, and that this angle is congruent to this. I'm simply just copying things from the first diagram to the second. So now we've got two angles congruent. We know that means we got a third angle congruent. We could even mark that in. Let me put, I kind of did that badly, but I wanted to put 3 measurements there. So we've actually got B and D as angles are congruent. That would give us angle, angle, angle. And that would not be good enough to prove that these two triangles are congruent. So what more do we have, or what more can we say that might be able to prove that these two triangles are congruent? Well, I hope you think what I'm thinking, which is that AC is equal to AC. Okay, we've got a shared side. Both of these triangles are sharing side AC. So that means that this side is equal to this side. That gives us an included side. So what we've got here is that side AC in both these triangles is included between two congruent angles. So in the first triangle, angle A is congruent to angle C, and angle C is congruent to angle A in the second triangle. So these are pairs of corresponding congruent angles, and between those pairs we have got an included side that is congruent. So this gives us angle, side, angle. And therefore, because of angle side angle, we can say that triangle ABC, and we have to be very careful about the way we refer to the second triangle. A is the double the triangle with the two angle marks. So that would be corresponding to angle C in the second triangle. Okay, so don't make the mistake of using A because it's the same letter. You're interested in looking at the measure of the angle, and what angle in the second triangle has the same measure as the angle in the first. So ABC in the first triangle will correspond to CDA in the second triangle. Okay, so again, let's go through that angle by angle. Angle A corresponds to angle C. Angle B, which is the triple angle here, corresponds to the triple angle here for D. Notice they're both opposite the single mark side. And finally, angle C corresponds to angle A. So the correct way to say it is that because of angle side angle, we have got a triangle ABC congruent to triangle CDA.